Hello, we are doing again section 10.2a, and I'm calling it A because 10.2 is really arithmetic sequences and series. We haven't even talked about series yet. I want to spend more time on arithmetic sequences. And even before reviewing this section again, I want to go back and review 10.1 and what we've learned in 10.2. So what I would do if I were you is get your notebook out, jot this down, hit pause, and that way you could think about the answer yourself. Like, for example, what is a sequence? You should hit pause because I'm about to give the answer. A sequence is simply a list of numbers with some type of pattern, right? A list of numbers. That's what a sequence is, a list of numbers. So you have to know that. Let's move on to the next question here. It says, what does the notation a sub n mean? So what does a sub n mean? Go ahead and hit pause, think about the answer, then I'll show it to you right now. The notation a sub n means the nth number on the list. I hope we understand that. A sub n is just the nth number on the list. So for example, if I said a sub 1, that'd be the first number on your list, right? If you have a 1 right here in place of n, then it'd be the first number on your list. A sub 5, the fifth number on your list. A sub 20, the 20th number on your list. I hope we understand that, guys. Let's move on to the next question here. What's the difference between arithmetic and geometric sequences? Go ahead and hit pause, think about that. What's the difference between an arithmetic sequence and a geometric sequence? And here's the answer. What's the difference between an arithmetic? Whoops, sorry about that. What's the difference between an arithmetic and geometric sequence? An arithmetic sequence has a common difference, which we call D, and a geometric sequence has a common ratio, which we call R. Okay, so understand that if there's a common difference, it's arithmetic. If there's a common ratio, it's geometric. So that brings us to the question: how do you find the common difference or the common ratio? Okay, so how do you find the common difference or the common ratio? Go ahead and pause it, think about it, and here comes the answer. Now let me bring this up a little. Here we go. So here's our answer. How do you find the common difference? Well, difference means to subtract, and you take the a sub nth number or term, whatever that may be, and subtract the a sub nth minus 1. Now, I know that sounds really confusing, but it's this simple. If you understand what a sub nth means, right, it could be the first number, the second number, the third number, the 17th number, and then you subtract, like let's say this was 17, the 17th number, and you subtract 17 minus 1, that would be the 16th number. So that means that you take a number and subtract the previous number from it, okay? Let me actually write this out for you. Let me demonstrate that. So we have a sequence right here, right? And what kind of sequence is it? Well, we said if it's arithmetic, there's a common difference. If it's geometric, there's a common ratio. How do you find the common difference or the common ratio? You take a number and subtract the previous one from it. Or you take a number and divide it by the previous number, okay? So again, if I were to label these, a sub 1 is my first one. A sub 2 is my second one. A sub 3 is negative 3. A sub 4 is negative 11. And you could go to any number you want, a sub n, okay? So let's say I was at a sub 4, which would be negative 11. And then I take away a sub n minus 1, which would be a sub 3, right? So I'm going to go negative 11, take away a negative 3. So let's actually find that common difference here. The common difference will be negative 11 minus a negative 3. Again, you take a sub 4 and subtract the previous one from it. Okay. What does that give us? Well, the minus minus changes to plus plus. We will get a negative 8. Okay. Maybe I should have done that in red. Negative 8, sorry. Or you could have taken the negative 3 and subtracted the previous one from it. Negative 3 take away 5. That will give us negative 8. Or you could have taken the 5 right here and subtracted 13, right? 5 take away 13 is also negative 8. As you can see, all of these are the same. They're negative 8. That is the common difference. The common difference is negative 8. What does that mean? that from here, 13, if I add the common difference, -8, 13 plus -8 is 5, 5 plus -8 is -3, -3 plus -8 is -11, and so on, so on, so on, continues on forever. Okay? That's how to find the common difference, right, if it's arithmetic. And we also need to know how to find the common ratio. Let's take a look at a geometric sequence. So right here we have a geometric sequence. How do I know? Because I made it. But anyway, how could we verify that it's a geometric sequence? Well, it has to have a common ratio. Obviously, it does not have a common difference. If you go -4, take away a -12, that's really -4 plus 12, which is +8. And if you did this one, -4/3 plus 4, that's not going to give you a +8. So there is no common difference. But there is a common ratio. So like, let's say I took any number. Let's say I pick the fraction -4/9. So I have -4/9, and I want to divide it by the previous number. So instead of putting it over -4/3, I'm going to write it horizontally, divided by -4/3. And of course, when you divide by a fraction, you really multiply by its reciprocal. So you're going to change the division to multiplication, and you're going to flip the second fraction only. So you're going to have a 3/4. It's still a negative fraction. And the first fraction stays the same, -4/9. So we need to actually multiply these two fractions, and we know that a negative times a negative equals a positive, okay? And we also know that the 4 up on top will cancel with the 4 on the bottom. The 3 up on top will cancel with 3 of the 9 on the bottom, leaving you 3, right? The fraction 3/9 will reduce by 3. 3 divided by 3 is 1. That's why there's nothing left, and 9 divided by 3 is 3. So you end up with negative times a negative, positive. There's nothing left up on top, which means a 1 up on top and a 3 on the bottom. So the common ratio is +1/3. R equals 1/3. Now, of course, you could do that with all the terms. You could go -4/3 divided by a -4, which will also give you +1/3. Or you could go -4 divided by -12. And that'll also reduce to +1/3. Anyways, I don't want to spend too much time on this review. Just want to make sure that we all know that we could identify arithmetic sequences by finding the common difference, D, and we could find whether a sequence is geometric if there's a common ratio, R, by taking, and it's always take a number and do something with the previous. Take a number, do something with the previous. Obviously, on differences, take a number, subtract the previous one from it. On geometric sequences, take a number and divide it by the previous one. Okay, so it's always picking a number and using the previous one. Okay, let's move on to the most important part of the section, arithmetic sequences, is to find the a sub nth rule of arithmetic sequences. So this is it, guys. This is what's super, super important on arithmetic sequences, how to be able to find the a sub nth rule. And of course, this is what you needed to memorize. A sub n equals a sub 1 plus parenthesis n minus 1 times the common difference d. Okay, so this, if you have the a sub 1 term, the first number on your list, and you're able to identify the common difference of that arithmetic sequence, then you'll be able to plug in your a sub 1 and your common difference d, and you could simplify by distributing and then combining like terms, and you'll have your machine that produces the arithmetic sequence. So I have a whole page of notes here. I hope you guys have a whole page of notes also. Let's move on to go and review what we did yesterday on the homework. On the homework yesterday, I asked you to do 20, 21, 22, and 23. And those were all based on a certain example number 2 from the textbook, which was really just writing an equation for the nth term. So you want that a sub nth rule, okay? So on all of these, you had to identify your a sub 1, which in this case was 24. You had to find the common difference by taking 46 take away 35, which would give you 11, or 35 take away 24, which would give you 11. So the common difference would be D. You'd plug it all in, you'd simplify, you'd have your machine that produces the list, right? It could be a little bit more complicated, like right here on number 22. They didn't give us a sub 1, they gave us a sub 9, and we had a common difference, -3. You could plug in a sub 9, which is the number 45, in place of a sub n, And then you could plug in the -3 for D, and you could solve for a sub 1 to be able to write your rule. If you had problems with that, please watch yesterday's video. Today, what I want to do is go back to example 1 and example 2. Again, revisit that, and you guys are going to do 4 questions for homework. That's right, only 4 questions. Similar to these 4 questions that we have right here that I want to go through right now. So number 1 says, find the indicated term of each arithmetic sequence. So they're telling you it's arithmetic. They're telling you that there's a common difference, which in number 1 is 9. They're telling you that the first term on your list is 14, and they're telling you n equals 11. Remember, a sub n means the number on your list. So if they're telling you n is 11, they're talking about a sub 11, which really means that they want you to find the 11th term on your list. So let's go back to our notebook. Let's jot down example 1 in our notebook. I guess it's question number 1, not example 1. So they want us to find the indicated term of each arithmetic sequence. So they want us to find the 11th term, okay? So we know that the first term, a sub 1, is 14. So imagine that. You got a 14, comma, and there's a common difference 9, and they want you to find the 11th term. So the second term, the third term, the fourth term, the fifth term, the sixth term, right? Where this one's a sub 1, this one's a sub 2, this one's a sub 3. This is the long way to do it, and I do not recommend it, right? What's the common difference? The common difference is 9, which means from 14, since the difference is positive 9, you're going to add 9 to it, and it'll give you a 23. Add 9 to it, it will give you a 32. Add 9 to it, it will give you a 41. Now you see why this is not a good idea, because if they say find the 25th term, you don't want to do this 25 times. Or if they say find the 111th term, you don't want to do this 111 times. Forget that. Let's use algebra, okay? Now, what do we mean by algebra? Well, let's write down our a sub nth rule for arithmetic sequences. The a sub nth rule is a sub n equals a sub 1. You always start with the first term. You are adding either a positive or negative number when it comes to arithmetic sequences between terms. And this is where we get the parenthesis n minus 1, and then times the common difference d. So let's plug in our a sub 1 value, which is 14, right here. We have the plus, we have the n minus 1, and let's also plug in the common difference 9 right here. Okay, and let's rewrite the rest. We have the equal sign, we have a sub n. However, they tell us, now remember, a sub n could be any number on the list, but they tell us they want it to be 11, all right? So they want us to plug in an 11 right there. If you wanted to, you could simplify this first by distributing 9 and then adding 14 to whatever answer you can. But since they're telling you they want the 11th term, you could plug in an 11 right away, which would mean a sub 11, that's just the notation saying the 11th term, equals 14 plus 11 minus 1 times 9. Okay, so we don't have to distribute anymore. Parentheses first, 11 take away 1, that's 10. So we have 10 times 9 plus 14. So what is 10 times 9? 10 times 9 is 90, and 90 plus 14 equals 104. So the a sub 11th term is 104. So they're asking us to find the 11th number. We just did that. We found the 11th number. How did we do that? Well, we took the a sub 1, which is necessary for our a sub nth rule. We took the common difference, which is necessary. We plugged in the 14 and the 9 right in here. If we wanted to, we could have actually simplified this. You know what? Just for funsies, let me do that right here. I'm going to take this a sub nth rule and I'm going to simplify it. What do I mean by that? I'm going to distribute that 9 times n, that's 9n. 9 times negative 1, that's negative 9. I still have the plus 14 out here in the front, right? This plus 14, I put it right there, plus 14. Let's combine like terms. When I combine the 14, take away 9, that'll give me a positive 5. So what do I have left? I have 9n with a positive 5. Ladies and gentlemen, that's my a sub nth rule, okay? They didn't ask us to write down the a sub nth term or the a sub nth rule. I want to show you that this is the machine that produces this list, 14, 23, 32, 41. Again, if you were to plug in a 1, 9 times 1 is 9, plus 5 is 14. That's your first number on the list. You see, 14. Plugged in a 2, it'll give you 23. Plug in a 3, it'll give you a 32. Plug in a 11, and we found out that the 11th truth was 104. Plug in an 11, 99 plus 5 is 104. This is the machine that produces the list. Okay, this list up here, I'm sorry. Let's move on and go back to number 2. They want us to find this notation says a sub 18. So they want us to find the indicated term. They want us to find the 18th number for 12, 25, 38. So let's jot that question down in our notebooks. Now I was thinking, my videos are getting kind of long because there's so much to talk about. If you get tired, hit pause right between problems, right? If you understood example 1, you could hit pause right now, get up, walk around, come back later, and then do example 2, and so on and so on. Take breaks. I just took a break right now. I went to the bathroom, came back, I hit pause, right? Wait, that's probably too much information. I'm sorry. Okay, example 2. Hopefully you took a break. Example 2, they want us to find the a sub 18th term. That means the 18th term for 12, 25, 38, and so on, all the way to 18. Right? So your a sub 1 term is 12, your a sub 2 term is 25, a sub 3 is 38, and they go a sub 4, a sub 5, a sub 6, all the way to, they want a sub 18. So let's understand, we already know a sub 1. Do we know a common difference? Well, we could find the common difference. Just go 25, take away 12. The common difference will be 25, take away 12, which is 13. Or if you would have done 38 take away 25, you'd still get 13. 38 take away 25, you still get 13. So that's telling us that the common difference is 13. Keep that in mind. So when you're writing an a sub nth rule, you need 2 things. You need that a sub 1, and then you have a plus sign, n minus 1, and you also need that common difference d, which we have. All right. So what do we have here? We have a sub n equals a sub 1, which is 12, plus n minus 1 times that common difference, 13. So this is an a sub nth rule. We could simplify it, make it nicer. Let's distribute. We have 13 times n, that's 13n. We have 13 times 1, that's a minus 13. And we also have a plus 12 out here. Let's combine the 12 with the minus 13, and we will get negative 1. So our a sub nth rule is a sub n equals 13n minus 1. This is the a sub nth rule. This is the machine that will produce the above list. What list? Right here, 12, 25, 38. If I plug in the number 1, it'll give me the first number, 12. If I plug in the number 3, it'll give me that third number, 38. Now, what do they want us to find? 18. So what am I going to plug in? I'm going to plug in 18 to find that 18th number on this list. So let's first begin by using the notation a sub 18. That's just the notation saying that I'm going to plug in 18. 13 times 18 minus 1. So 13 times 18 is 234. And we're going to subtract 1, okay, from it. So the 18th number, a sub 18, is 233. Okay. I hope we understand that. That's all the work for number 2. This is not your homework, but this is very, very similar to your homework. Let's move on to the next 2 questions. And again, you're only going to have 4 of them for homework. Let's do this one. It says write an equation. We've been doing that. We've been doing the a sub nth equation for these guys. So this is just the same thing. Write an equation for the nth term of the arithmetic sequence. They want the a sub nth rule. They want the equation for the nth term. So let's take number 3 right here and write it in our notebook. So let's write the a sub, whoa, what happened there? Sorry about that. Let's write the a sub nth rule. It's not sticking onto my paper. What's going on? There we go. Let's write the a sub nth rule to this arithmetic sequence. A sub n equals a sub 1, the first number on your list, plus parenthesis n minus 1 times that common difference d. Do we know the a sub 1 term? Yes, that's 13. So we're going to put a 13 right here as the a sub 1. We're going to keep the plus, the n minus 1. We do have a common difference. What is that common difference? Pick any number and subtract the previous one from it. 25 take away 19 is 6. So our common difference will be 6. And it doesn't matter if we picked this one, take away this one, or we could have gone 19, take away 13. That's also 6. The common difference is 6, which means that in place of the variable d, I will put times 6 right there. If you don't like using the multiplication dot, you could put parentheses if you want, or just remember that you're multiplying. You're going to end up distributing. So let's simplify this a sub nth rule. 6 times n is 6n. 6 times minus 1 is minus 6. Bring down the plus and the 13. Then you could combine like terms. Let's begin with the 6n and just rewrite it since there's nothing to combine it with. But then we could actually go 13, take away 6, and that will be a positive 7. So the a sub nth rule for number 3, a sub n is 6n plus 7. Now, if you're not too confident in your rule, go ahead and plug in the number 1, see if it gives you 13. Or plug in the number 3, see if it gives you 25. Plug in the number 2, see if it gives you 19, which it will. Fourth question, which is the most challenging one. Let's jot down this fourth question. We want to write an equation for the a sub nth rule, the nth term of this arithmetic sequence. And in this case, they don't give you a sub 1, they give you a sub 5. So I've written down number 4 right here in my notebook. And let's write down our a sub nth rule. And in order for this to work, I need my a sub 1 and my common difference. Well, I know my common difference is negative 4, but they don't give me a sub 1, they give me a sub 5. So notice, instead of a sub n, we could replace a sub n with a sub 5. Okay, now this is as confusing as it gets. A sub 5 instead of a sub n, right? Now, what does that mean? This 5 right here, this a sub 5, when I write out the rest of my equation here, a sub 1, we don't know a sub 1, so I leave it a sub 1, plus n minus 1. Now, instead of me writing n, well, we know that this n got replaced with this 5, which means that the n is supposed to be replaced with 5. Okay, and we do have this common difference over here of negative 4, so that d is going to get replaced with negative 4. Okay, and this right here, what we're doing here is taking what they give us to find out what we need, right? What do we need? We need a sub 1 and we need the d. We already have the common difference. We don't have the a sub 1. Let's find the a sub 1. So let's find the a sub 1 by simplifying all this and solving for a sub 1. So 5 take away 1 is 4. So we have 4 times negative 4. We do have this plus sign and the a sub 1 over here equals. Now, instead of a sub 5, that's not going to help me if I leave it a sub 5. I want a number over here. As you can see, a sub 5 does equal negative 12. So let's put a negative 12 right here in place of a sub 5. Now I have an equation with a bunch of numbers and just one variable that I could solve for. So what is 14 times negative 14? That's negative 16. We have an a sub 1 right in front of it, the equal sign, the negative 12 right there. We need to get a sub 1 all by itself. I want to get rid of this minus 16. So I'm going to add 16. It'll cancel out. What I do to one side, I do to the other side. I will have 4 equaling a sub 1. A sub 1 equals 4, ladies and gentlemen. So again, whenever they ask you to write your a sub nth rule, you need to have that memorized. You need to identify your a sub 1, which happens to be 4 in this case, and your common difference, which happens to be negative 4 in this case. So our answer to number 4, writing the a sub nth rule, a sub n equals a sub 1, which we said was 4, plus n minus 1 times that common difference d, which happens to be negative 4. So let's distribute the negative 4. I mean, this is your rule, but it's ugly. It's not simplified. You have to distribute and then combine like terms to make it as nice as possible. So negative 4 times n, that's negative 4n. Negative 4 times negative 4 is positive 4. Bring down the 4 that's in the front, bring down the equal sign, and the name of it, a sub n. After that, these three terms, two of them could be combined. 4 plus 4 is 8. So my final a sub nth rule is negative 4n, because I couldn't combine negative 4n with anything, plus 8. This is it, guys. This is the machine that produces the list, right? As a matter of fact, we didn't even have the list, right? We have the fifth term on the list. This is the machine that produces the list if we had the list. If I wanted to, I could plug in a 1 and it would give me the first number on the list. I could plug in a 2, give me the second number on the list. I could plug in a 3. I could plug in a 5, and it should give me this fifth number on the list. Plug in a 5. Negative 4 times 5 is negative 20. Negative 20 plus 8 is negative 12, which is the fifth number on the list. That's the algebraic way of doing it. There's also a logical numeric way of doing it, which I do not recommend, okay? But I just want you to really understand this. So let me take this this exact question, duplicate it, and then bring it down over here. And let's look at it in a different light. What do I mean by that? Let's say that we want to just show that the fifth term is negative 12. That's the fifth term. That is a sub 5 right there, which means that the one before it or the one after it are here and here. So a sub 6 will be, if your common difference is negative 4, negative 12 with a negative 4 combined will give you negative 16. And so on and so on. With the negative 4 will give you a negative 20, right? And if you're going backwards, instead of subtracting 4 this way, it'd be adding 4 this way. So plus 4 would give you a negative 8. Plus 4 will give you a negative 4. Plus 4 will give you a 0. Plus 4 will give you a 4. Let me see. Do we have 5, 4, 3, 2, 1? There you go. So your list really does begin with a sub 1, which is 4, a sub 2, which is 0, a sub 3, which is negative 4, a sub 4, which is negative 8, a sub 5, which is negative 12. And that's the list. That's using logic. I do not recommend that. I recommend you using the algebra. But I just want you to really understand that this information does come from this list, and it could be applied that way. The reason why I don't want you to think of it numerically with the common difference is because what if I told you a sub 35 and then you want to count down to the first number? That'd be crazy. But as you can see, we got that first number logically. We got that first number algebraically, looking at it in all angles here. So this is it, guys. These 4 questions are almost identical to the ones from your homework. Your homework is right here. We're doing 1, 2, 3, and 4. Same deal, okay? Find the indicated term. They want you to find the 73rd term, where your first term is 56, common difference is 13. Write the a sub nth rule, plug in 73, you'll have the 73rd term. This one right here, you're going to have to write the a sub nth rule. You're going to have to plug in a sub 19 into that first one and work your way through it using algebra. Go back and watch the examples over again if you need to. Questions 3 and 4, nice and simple. You want to write the a sub nth rule, and that's it, right? So find the common difference, and then find the first term, plug it all in, simplify it, you'll be done. And again, just to wrap up the video here, the title of this section is Arithmetic Sequences and Series. We've only been talking about the sequences. We haven't even mentioned series yet. That's going to be 10.2b when we talk about series. We'll do that on the next lesson.